Hello student, last lecture we take the laws of logarithm. So today we start from the revision of laws of logarithm. Log of 1 to the base b is equal to 0. Log of b, that means log of b to the base b is equal to 1. That means these two numbers must be same. Then we derive the value is 1. That is base and number is same. Then we get the value 1. Products log x into y to the base b is equal to log x to the base b plus log y to the base b. We take examples. If I put x equal to 2, y is equal to 3 to the base 5 is equal to log 2 to the base 5 plus log 3 to the base 5. Quotient x and upon y must be different numbers, that is unique numbers, and b is any base. Then log x upon y to the base b is equal to log x to the base b minus log y to the base b. If I put x equal to 3, y is equal to 7 and base b is equal to 2, we derive log 3 to the base 2 minus log 7 to the base 2. Towards up to reciprocal form, we just look the power function law. Log x raised to n to the base b is equal to n log x to the base b. That this n goes to this one derived from this and goes to left hand side of the log function. For example, I put x equal to 8, n is equal to 2, b is equal to 10. Then we derive 2 log 8 to the base 10. These power function law of logarithm, we have to improve the reciprocal law. How? We know that 1 upon x we can write x raised to minus 1. So it goes to minus 1 in an index form. That's why n is equal to minus 1. We have to use this term. How we derive? Log 1 upon x. It is x raised to minus 1. So minus 1 into log x to the base b. For example, log 1 upon 7 to the base 2. I put the value of x equal to 7 and the value of b is equal to 2. We derive direct from this formula minus log 7 to the base 2. In a detail, we have to must discuss about the all laws of logarithm with examples. First law of logarithm, that is log 1 to any base is always 0. Log a to the base a is equal to 1. Log e to the base e is equal to 1. These are the fixed laws. Only here number must be same. First example, find log 3 to the base 3. First we have to must verify the base and number must be same in given example. So we have log a to the base a is equal to 1. We put a is equal to 3. So we derive the value log 3 to the base 3 is equal to 1. Just take the example for classwork and homework. Log 5 to the base 5. Log 1 upon 3 to the base 1 upon 3. We detailed study about the laws of logarithm with power function law. What does that means? Log m raised to n. These are same number or different number, does not matter, but these index number goes to left hand side of log and m remain as the same. Suppose example from exercise we have to take. Find log 125 to the base 5. Solution, we know that 5 raised to 3 is equal to 125. I check here 5 is the base. That's why I split up the 125 in a form of 5 raised to 3. So I put instead of 125, 5 raised to 3 is there. I clearly mentioned that 5 and number 5 and base is same, but instead of 3 we have to shift. So we have these laws of power law of logarithm. That means log m raised to n is equal to n log of m. I put n is equal to 3, m is equal to 5. So we derive these 3 log 5 base 5 to the base 5. We know that log a to the base a is equal to 1. So log 5 to the base 5 is equal to 1. So 3 into 1, obviously 3. So we derive the final answer, log 125 to the base 5 is equal to 3. Next, log m plus log n is equal to log m into n. That is the product law of logarithm. I take the reverse way. What is that? Addition of both log gives the multiplication of that both terms. For example, log 5 plus log 3. We have log m plus log n is equal to log m into n. I put the value m is equal to 5, n is equal to 3 in above expression of the left hand side. So I have the m is equal to 5, n is equal to 3. So log 5 plus log 3 is equal to log 5 into 3. So log 15. So final answer, we derive log 5 plus log 3 is log 1, 5. That means the product of these two numbers. You have to must remind. I give hint about this property, that is log m plus log n, that is addition is there. So we derive the multiplication between the numbers. Next, very important law of logarithm, that is the quotient law. I get the reverse way. How? If subtraction is there, I can divide that quotient form. That is log m minus log n gives log m upon n. For example, find log 3 minus log 2. I have just the laws of logarithm, log m minus log n, because negative sign is there, so we have to use log m upon n. I put m is equal to 3, n is equal to 2. We derive the value log 3 minus log 2 is equal to log 3 upon 2. So we derive the final answer is log 3 upon 2. Given hint or remind these laws of logarithm, always remind that if log m and log n have the subtraction, then it goes to division and log remain same. We take the example for a practice. So you have to must practice as a homework. First example, log 81 to the base 3. Find log 61 to the base 2. You have to must, in these two examples, you have to must convert the 81 in a form of 3, 64 in a form of 2. By given the example log 125 to the base 5. Here base is important in this example. Now I given the question, convert the following into single logarithm. So I have the first example, log 4 plus log 7 to any base, log 2 plus log 5 to any base, log 5 minus log 3, and the last example, log 2 minus log 9. Verify and clear about that these both numbers must be unique numbers. Then we have to solve this example. To note down the example for the practice at home. We have all laws of logarithm. So we take the example from exercise for the 4 marks question. Find log 32 to the base 4 plus log 2 to the base 4. Second one, log 270 to the base 3 minus log 10 to the base 3. Third one, log 1 upon third root of 5. That is means that cube root of 5. That is log, I once again explain, log 1 upon cube root of 5 to the base 5. Fourth example, that is D, log 12 to the base 2 plus log 3 to the base 2 minus log 9 to the base 2. Next example, the last one, log to the base 3, that is 4 is there, under root 1 upon 81. That is called fourth root of the log of 1 upon 81. So these example asked in a board exam for the 4 marks question. Using laws of logarithm, using law of indices, using laws of exponent and simplify the terms, we get the answers of these examples. We discuss these by and solve these examples by one. For solving these examples, you note down that we have to must revise all the laws of logarithm in 2 minutes. In all these examples, you note down these examples solve when by laws of logarithm the base of each term must be same. Here base is 4, here also 4, laws of logarithm applicable. Here base is 3, here is also base 3, so laws of logarithm is applicable. Here base is 5, but they given in numbers, so we have to convert that in a form of 5, so easily we can solve these. Here also in a fourth example, base is 2, base is 2, base is 2, then we can apply easily laws of logarithm. Here also 3 is there and they give the term in a form of 3's power, so we can convert these in easily format using the laws of logarithm.